find some proportional parts. This is part 2. We did part 1 on Friday. It's going to feel really familiar to Friday. Just our biggest change today is, yes, on Friday, I keep saying yesterday. On Friday we were dealing with, you could kind of see the triangles that were overlapping each other. We had like this blue triangle that was on top of this yellow triangle, and it created those parts. Okay, and today it's going to cut off the tip of that triangle. So it's going to actually end up with 3 parallel lines because we're going to cut off just that front part. So it's like we could create triangles, but we're not creating the full triangle. So for our theorem here, it's 3 or more parallel lines are cut by 2 transversals. So remember, a transversal is just a line that goes through the same lines. Then there are proportional parts on the transversals. Okay, so that's kind of a lot to write. Let's go ahead and get that written out. And then you're going to get a glue in. This can just get glued in underneath, either on the left or the right side. I like it on the left side because I like to write on the right, but other people have different preferences. So go ahead and glue this in, either on the left or the right. Alright, so I get that glued in, and then as you glue that in, if you want to find the colored pencil box, we're going to use a couple colors as we go through. There's a couple. We'll have just a couple of them, but we'll use more colors on the first one than we'll do on the others. Alright, so go ahead and get that glued in, and then if you want to find some colored pencils, somebody took my glue. Alright, so as we take a look at this first diagram, let's take a look and see which ones are the parallel lines. So for our parallel lines, those are the ones with the arrows. They're running side to the sides of each other. They aren't going to intersect with each other ever. So we have A, W is one of them. we're also have a parallel line. And it might be easier to see your letters on your diagram. So if AW is parallel to good, BX and CY. Okay, so we can write that out, that AW, and that's a line, so we're going to put that line above it with the arrows on both sides, is parallel, so we use those two little slashes to show parallel, to BX, which then is parallel to CY. So that's always the start of our theorem. We have to have an if, a given. The given part of this is that we have to see that those are parallel. So we see that those are parallel. Then because of that, we can write different proportions. Okay, so because of that, our proportions that we can compare are on those opposite transversals. So our transversals that cut through are this WY at the bottom and this AC that cuts through the top. So because of that, we have these three proportions that are equal to each other. Remember, proportions are just showing that ratios are the same. Those numbers are the same. So we have three of them. Okay, the first one is that we can compare this AB at the top and what could we compare AB with down at the bottom? WX. It's just like we just move over and see which one it compares to on the bottom, and it'd be WX. I always like to think about these parallel lines kind of as lanes. Like if you stay in the lane, it brings you to the other one. Okay, then up here we have BC. And BC would be proportional to XY. And then our last part that we can write a proportion for is the total length. So from A all the way to C. Which might sharpen, it's not quite sharpened, so I'm going to just highlight in color. Would be the same as W all the way to Y. All right, so as we take a look, we have just two examples that we're working through here today. And again, it's going to just be about setting up the proportion, and then once that proportion is set up, we're going to be able to just solve it just like how we've been solving all our proportions. Hi. Here you go, dear. Mm-hmm. All right, so in this first one, we're trying to find the question mark. So question mark, we always like to start in that numerator. In your practice today, that will already be set up for you where the question mark's in the top. Now we need to decide what the question mark can be compared to. And then remember, there's a couple ways to get this set up. So there's a couple relationships. What could I put that question mark with? And again, it might be a little easier to see on yours here. It's a little zoomed out. So what number would you put with that question mark? Ishmael, what number would you put that with that question mark? What other number would you pair with it? 27? Sure. Okay, we can compare that with the 27 because it's on the same side. So we can put 27 here. That works. Now as I go to the other one's going to be the other side. So I want to kind of show what parts those match with over here. So I'm starting with the smaller part. Would that be the 8 or the 10 that matches with that question mark? If I stay in that lane and I drive down that lane, it matches with 8. So I'll put 8 on top. But then for the 27 is the whole length. That's what those little lines mean. It means from here to here. So for the bottom part there, we need the whole length all the way across, which we have 8 and 10. So together that would be 18. All right, if you set this up as a different way, if you were working ahead, another one that would have worked is putting question mark over 8 and then 27 over 18. Okay, so remember there's a couple ways to set these up. All right, so then as we solve it, we're trying to get the question mark by itself. So I'm going to get rid of that 27. So how would I undo that 27 that's with the question mark? This line means we're doing what? This is our division line. So to undo division, we multiply. If we multiply one side, multiply the other side. On the left side here, that just undoes the 27, and we're left with a question mark equals. On the left side here, we actually have to do that math. So we're going to do 8 divided by 18 times 27. I'll give you a hint today that all your work is going to end up in whole numbers. So if you get a decimal number, something is not quite right. That's your hint to you. So our answer is 12. All right, we have one more to do. Oh, Jeremiah. Zach. Guys. Psst. What is happening up there? They're just having a whole in own life. All right, as we go to this next one. This one we're going to solve for x, so it's a little bit different. Because this time we don't just have a question mark, we have an x to look for. We're going to start setting it up the same way with our ratios that are equal to each other. And we always want that unknown to be in that first numerator. So in that first numerator, we have that part with the x here, this negative 7 plus 4x. Okay, and then we want to set that up so that we can find those parts that we're going to compare it to. I'm going to drive down that lane first this time. So negative 7 plus 4x, if I go across that street, we end up at this spot here, which is not filled in for us. I know one part is 9. The whole thing is 24. So how can I use those two numbers to find this missing part? Say it again. So. 24 minus 9. There we go. Okay. I literally could not hear what you were saying. Sorry. So 24 minus 9 is 15. So we know that this amount is 15. Okay, so we're going to compare it to 15. Then when I go with that back to that where the x is located, what else on this transversal do we know? The other part that we know is this bottom 15. And then I'm going to travel across that lane, across the street here. If I stay in that lane, I compare it to 9. All right, and then we're going to solve that for the x. That's our goal. So remember when x is on top like that with that numerator, this is like it's in an invisible parentheses. So we can't touch this top part until we get rid of the bottom part. So we have to undo that dividing by 15 first. So we're going to multiply by 15. So we get negative 7 plus 4x, just the top part. The 15s are gone. And then in our calculator, we'll do 15 divided by 9 times 15. And we get 25. All right, and then we're solving just that two-step equation. So to get x by itself, do we undo the 4 next or the negative 7? Yep, the negative 7. And how do we get rid of a negative? We add a positive to both sides. So bring down that 4x equals 25 plus 7. It's 32. And then to get x by itself, we have to undo that multiplying by 4. So we divide by 4. And x would equal 8. If you need to use a calculator for that, go ahead. All right, on your practice today, there's a couple problems like this. With this problem in your practice, I'm not having you write everything. I'm going to have you write this first step of how to set it up. I'm having you write the second step and then the last step. So there's only 3 parts that you'll write. So if you need to use a whiteboard as you solve this because you need to show your work, do that. All right, and that's it for our notes today.